Okay, now number 26. 26 is 6 square root 48 x squared minus 2 times square root 27 x squared minus 3 square root x squared. No, pero 3 inside the radical. Es square root 3x squared. Okay, we start with 48. 48 is even number. Divided by 2 is 24. Divided by 2 is 12. Divided by 2 is 6. Divided by 2 is 3. The classical prime factorization. And you see a couple 2. Both sides go 1, 2. Another 2 is this couple. Multiplication each other is 4. And 4 times 6, 24. 24 what? Well. The 3 stay here. These 3 stay inside the radical. So it's radical 3. This is the analysis of the only numerical part, is 48. The analysis for the variable part is x squared. Is super easy because when it's even number, you divide by 2. Remember the square root have invisible 2 here, right? And you divide 2 divided by 2 is 1. Therefore, it's obvious that we have 1x only outside. Another way to see this idea, x squared is x times x, no? And x times x is a couple, it go outside like only 1x. And inside the radical we have nothing because it's even and matching perfectly by couple. Now 27. You take the number, you get the number inside. It's 3933. So basically 27 is the multiplication 3. And we have a couple 3. The 1 3 outside. And the 3 can go outside, multiplied by 2 is outside. Before, at the beginning, is minus 6. Radical 3. This 3 stay here. Likewise, 1x outside. Okay, I forgot here. Minus 6x. Minus, in this case, the only possibility of simplification is in the variable part because 3 is a prime number. So this x go outside, x radical 3. And you believe, or you see, you realize, okay, this is light term. Light term, guys, and definition is you have the same variable, the same number, the same variable, yes, the same exponent. It's x. So see, you combine. But of course, you involve somehow an irrational number, but it's okay, no problem. You subtracting 24 minus 6 is 18. Let me see, carry that one. See, yes, it's 18. Minus 1, because this is invisible 1, you know, is 17. The answer is 17 x radical 3. Boom. Final answer. We check 17. Yeah, option A. Cool. No problem. Everyone follow me? Okay.
Yes.
Okay. I understand that this is easy. Well, so now we have another problem involving the higher roots, maybe for root or cubic root. And remember, the idea is when you have a square root, you select by couple. But when you have 4 root, you select 4 by 4. And if you have cubic root, you select 3 by 3. Okay, so no problem. It's 9 is 9. 4 root of x to the 7 power minus 4x 4 root again of cubic power. Okay, let me try. Is one possibility is x to the 7 power is 1, 2, 3, 4, 5, 6, and 7x multiplication each other. However, I can see 4 go outside like a 1x. Okay, so the answer is 9, 1x, and stay alive inside the 4 root 1, 2, 3, x to the 3rd power. This method is good, but the only disadvantage is I put x to the 7 power. Wow, that's too low. Another possibility is you break it down in your mind. X to the 7 and x to the 4 and x to the 3rd. How do you know get 4 and 3? Because you try to find the multiple of 4, the exact multiple of 4 close to 7, pero down. Entonces es obvio que el múltiplo of 4, exact múltiplo of 4 es 4, es 8, es 12, 16, 20. You take 4. No 8, because 8 is too much. Entonces es x to the 4, and the other is x to the 3rd, because 4 plus 3 is 7. And when you apply 4 root of this, it's obvious, 4 root separately. It's obvious that this is just x. And very, very important, when the power inside the right is smaller, is less than the index, you cannot simplification anymore. Because actually we have x to the 3rd power. Okay, and x to the 3rd is x, and x. And to find 4 root, we have a minimum 4 element. And we have only 3, so it's impossible simplification. So in this case, it's obvious que it's impossible simplification. And the second one, just copy 4x, 4 root of x cubed. Oh, but you see something funny. They are lighter because we have the same variable and the same exponent. Therefore, you combine. How we combine? Subtraction, because it's minus. So say it's 9 minus 45 x 4 roots x to the power. It's the final answer. Let me see. Wow, fantastic is this guy. Cool. Now one example of the cubic. Remember, in cubic you select 3 by 3, or in the scenario of the variable, you try to break it down using multiple of 3, exact multiple of 3, so 3, 6, 9, 12, and so on. Let me try 28. In 28 we have 4 cubic root of a plus, no coefficients, I suppose que es 1 cubic root a. Well, in the first one, we cannot do anything because we have only one a, and the minimum element we need to simplify is okay. But the second one, we have a, but we have 8. The numerical part is 2, 4, 2, 2. It's exactly the amount of 2, sorry, that we need to simplification. This 2, 2, 2, 3, 2 represent 1, 2 outside the cubic root. And this is no surprise. Some students memorize que cubic root of a is 2. Okay? Entonces, what is the answer? The answer is 4. You copy this exactly the same, no change. not do anything. Plus now we have 2 outside. These 2 fly outside and multiply by invisible 1 that we have here. 2. And let's take cubic root of a, no? Because the only guy can stay alone. This is 6. Combine like term again. Cubic root a. This is a typical example in which you are doing well. And the last line, everything is lighter. You see, everything is lighter. You condensing 2 radical, 3 radical, and only 1. Okay, cool. No problema.
No.
Follow me? No.
Yes, Professor.
Okay, cool. Let me try what is the next. No problem. Next is chapter 4. Okay, we did this. I don't know. Let me link to page. I'm not sure. This page. Okay. Oh yeah. Okay. We are doing one by one. Okay, we continue this. We focus in this. Okay. 29 and 30 is very similar as the thing we are doing, but it's cubic root. So it's 2 cubic root of 27x plus 2 cubic root 125x. Ah, this is easy. If you know cubic root 27 is 3 and cubic root 125 is 5. You don't know, no problem, because the factorization is 27 is divisible by 3, get 9, 3 and 3. Okay, 9 is exactly the amount of 3 we need to simplify and go outside 1, 3, and these 3 fly and multiply by these 2 meet. And this is 6 cubic root something. Numerical part, nothing inside, because these 3 go outside like a 1, 3, and stay only x. And here exactly the same, because it's divided by 5, 25, and 25, 5, and 5. You can do directly, so you know by memory, the cubic root 125 and 27, no? So you don't know, no problem. You take the calculator and divide by 5 systematically. Divide by 5, divided by 5. Now, this is 1, 5. Both side and 5 multiplied by 2 is 10. 10 cubic root of x. Entonces 16 cubic root of x is the final answer. There you go. Option C. It's easy, eh? One more. May I erase the board or no?
Yes.
Now let's move on to problem 30. 30 say 9 cubic root of m to the 7 b to the 5 minus 5 m squared outside and p cubic root of m p squared. And remember, no number is just variable expression. Therefore, we can simplification because in my mind, m7, I break it down like an m cubic and m4. Okay, so 9, just bring down. You open the cubic root And the challenge is find how many m go outside, how many m stay inside the radical. Well, we break it down mentally. 7 and 3 and 4. And 3 divided by 3 is 1. So 1m go outside and 4m stay. No. I am crazy. No. It's wrong. Wrong. Well, we can break it down this, but we continue. So it's what is the multiple of 7 close to multiple of 3, sorry, close to 7, is 6. And 6 divided by 3 is 2, so m to the second power. Okay, and 1m stay. Okay, another way to visualize this. More visual. N to the 7 is 1, 2, 3, 5, 6, and 7. I need to select 3 by 3 because it's cubic root. One triplet of m, another triplet of m. This go outside like a 1m, and this go outside like a m. Therefore, outside we have m squared, is this. And inside stay is more clear, right? I like this way. When the number is not too big, when the number is big, say 40, 70, 100, so you are doing different, no? Okay, so let me try to, it's 9 m squared so far, but I give you a space here for the p. P. How many p? How many p outside? How many p stay inside? P. P is 5. P is 5. P to the 5th power. How many? How many?
2 inside.
2 inside. And outside nothing. No p. How
1.
many? 1. Very
1.
good. Because the P, 5p, no? However, we have only one triplet of p que represent this 3p represent that p. Represent that p. And stay 2p que es p squared. Nice. And I know this in the second we cannot do anything. Why? How do you know, professor? Because the exponent of the variable is 1, que is smaller than 3, and 2, que is smaller than 3, so we cannot do anything. And we can simplification when the exponent is bigger than the index, but si es smaller, no simplification. Somebody do that before. Okay, now ready, because I realize one more time that they are lighter, same exponent, same radical, everything. The only thing they change is the coefficients, que es 9 and 5, subtracting 4. M squared P root M P squared. Finals. Now let me see. Option C. Okay? Easy. Now, we study another completely different idea. Case rationalization. Let me explain in detail. What means rationalize? Well, we have expression. When you have expression, and this expression contains radical, but radical in the denominator, we need to eliminate the radical in the denominator. Okay, for example, 31st, 7 over radical 2. And the command say, well, rationalize the denominator. I need to do something here in order to remove this radical in the denominator. Okay. And the key idea is always the same. When it's monomial, it's easy. You create the smart one, que is the same. You multiply by radical 2 and radical 2. So this is artificial factor that introduce because I want to rationalize. This is a smart one. Okay? This is my original problem, no? In order to doesn't affect my original problem, you multiply by smart one. This smart one help me to this because I know that radical 2 by radical 2 is radical 4, no? And radical 4 is 2. Wow. So I can generalize radical any number times radical any number. By the way, this number must be the same. The different no. Is equal any number without radical. Suppose radical 5 times radical 5 is 5. Radical 3 times radical 3 is 3. Radical x times radical x is x. Okay, cool. This idea is fantastic and help me to rationalize. Okay, now. This is my original problem. I multiply by smart one, and you multiply multiplication fraction. It's super easy. Multiply top, bottom. It's 7 radical 2. And radical 2 times radical 2 is 2. Boom, final answer. This expression, wait, this expression and this expression are equivalent. It's the same value. However, this is not rationalized and this is rationalized. So the answer is 7 radical 2 over 2. Do you follow me? Yes or no?
Yes.
Let's practice operation. Okay, let's practice operation with the radical. Es la que no es illegal, ¿no? Pero es polite, elegant. To express it, final answer. Okay. En Alex, y no only en Alex, any software. When you write final answer of something and you don't rationalize the denominator, some software consider that this answer is wrong. Actually, it's not wrong, but it's not polite. But they want the polite answer. And remember, Alex is a robot. Okay, so now let's move to 32. 32 say minus square root 25 over 12. Bueno, rationalize. Well, first of all, we have a fraction. We have a minus, but this minus, I don't care too much. This minus I keep here from the beginning up to the last moment. And you separate square root 25 and square root 12. I know very well that square root 25 is 5, but the square root 12 is no perfect square. And this answer is correct, however, it's not rationalized. Let's do something. First of all, let me try to break it down 12. In this case, 2, 6, 2, 3. You see that we have a couple of 2. Now we can simplification like a minus 5 over 2 radical 3. It's okay? This is equivalent. So instead of radical 12, is 2 radical 3. It's equivalent, no? So the minus 5 to radical 3. And this is a crucial moment in which you rationalize and you create the smart one, que es radical 3, radical 3. Okay, entonces now in the top we have minus 5 radical 3. In the bottom we have radical 3 times radical 3 is 3 and 3 times 2 is 6. Oh. Well, as all we have been, you put a negative in the top, the negative in the bottom. or the negative in the middle, que in my opinion is more elegant. Like that. Boom, this answer. Okay, let's practice. Rationalize. Rationalize, in this case, monomial, que es super easy. Binomial is a little bit more complicated, and we study after that. Okay? Okay. Monomial is easy. You create the smart one, and take advantage of the property. This property is super important. Radical any number or expression times radical any number or any expression is equal to any without radical. It's the magic way to disappear, to remove the radical. Okay, 33. 9 over radical 5. Oh, it's easy. The smart one is radical 5 radical 5. And we have 9 radical 5 over 5. See? This answer. 34 is 9 radical 2 is similar. The smart one is radical 2. Is 9 radical 2 over 2. Okay, 35 is no similar. It's a little bit different because we have fraction inside the radical. But immediately you have fraction inside the radical. You separate radical numerator, radical denominator. Fortunately, square root 49 is 7. And now we convert the problem in one problem very, very similar to this and this. Create the smart one, radical 2, radical 2, 7, radical 2, divided by 2. Now, 36. 36 is square root 50 over x. You apply radical 50, radical x. This is different to this because in this case 49 is perfect square number, 50 no. But don't worry too much because as always, I try to break it down. No? 50 is even number, it's 25, 25, 5, 5. It is called the couple of 5 that we need. So 5 go outside, and radical 50 is 5 radical 2. Because this 2 is this 2. Over radical 5. And finish. No, I need to rationalize. Radical 5, radical x, radical x. Entonces 5 radical, if you want, you put together. Yeah, it's more elegant. Put together. No, you can write radical 2 times radical x. This is correct, but much better join in only one radical. And the bottom is x. Apply the property que radical any expression or number is equal any without radical. Entonces something like that. Only. Let's see, eh? Okay, let's move on to the next. Okay, I need to explain something. Now we are doing rationalization and binomial. I need to multiply expression que contain radical. It's very, very important to understand the rule. Suppose we have 5 radical 2. This is theoretical, guys. Multiplication by 2 radical 3. The rule is you multiply completely independent the coefficient outside and the coefficients inside. So we cannot mix it. because these belong to different categories. 5 times 2 is 10, and 2 times 3 is 6. That's the answer. And this 6 is impossible simplification because 6 is 2 and 3, and we have no couple, and it's the final. So this is the rule. You copy exterior number and interior number separately. No mix everything. Okay? Now, I want to explain another thing. When you have binomial like a plus b, you know very, very well, if you multiply by the conjugate, remember the conjugate is same numbers or radical or variable, but completely opposite signs. See, one is positive or negative, this is conjugate. The technical name of this guy is conjugate. You know very well that the answer is a squared minus b squared. The problem is that we are doing all the time in this direction that we use it to factorization. But I am using this formula in this direction, gets multiplication. So if you have, for example, the multiplication to conjugate, for example, 7 minus radical 2. What is the conjugate of 7 minus radical 2? Oh, is 7 plus radical 2. And look what happened magically. Is, according to this formula, you square the first, get 49. That's 7 times 7 squared minus radical 2. Radical 2 is 2, no? It's 2. That's 47. Wow, professor, I don't understand very well this. Bueno, we're using the formula, okay, pero si you're using FOIL, let's doing FOIL. It's doing FOIL. FOIL is 7 times 7 is 49. 7 times radical 2 is 7 radical 2. Remember, we cannot mix it, this 7 and this 2, because this 7 is just a number, a whole number, okay, have no radical. And this radical 2, okay, I believe okay, the coefficient is 1. 7 times 1 is 7, and 2 stay. Now, multiplication, this is minus 7 radical 2. It's the same, but opposite sign. And finally, radical 7, radical 2 times radical 2 is 2, but it's negative time positive is negative. So it's negative 2. I guarantee you, you don't need to do this. This is cancelled always when you are doing the multiplication of conjugate. Okay, so basically the answer is square refers, is exactly this formula say. In our example is 7. 7 squared 49. Look at that, and look at that, it's the same. Minus always because the difference of a square, and square the second que radical 2 squared is 2. It's these two, it's these two, and the answer is the same. And we take advantage this fact to rationalize binomial. You create the smart one. Suppose example 37. 37 say 5 over 7 minus radical 2. And the question say, rationalize the denominator. Assume that all variables represent positive number. Blah. This is blah, blah, blah. It's not important. The important is I need to do something in order to eliminate this radical in the bottom. Entonces, you create one more time the smart one. The smart one is formed by conjugate of the expression in the denominator. Okay, 7 plus radical 5, radical 2. Okay, radical 2. The top is pretty easy. You multiply this, you multiply this. It's 35 plus 5 radical 2. Remember, one more time, I repeat. When you multiply 5 times radical 2, you multiply 5 times the invisible one. Because there are no possibility to multiply number outside. This is completely illegal, guys. It's external, external, interior, interior, interior. And the bottom I did. In this example, the answer is 47. It's magic. Disappear the radical, the multiplication of the conjugate. The answer is this one. You understand? Confusing. All right, guys. Is it confusing or no? It's confusing, eh? Yes. Any guy say yes, but yes is confusing or clear? Anika. Okay, so I propose you. Si it's confusing, I propose you temporary.
It's kind of confusing.
Yeah, I know, I know. So I propose you to clarify this idea. Skip for a moment, of course. Skip 38, 39, 40, and 41. Very no? Okay, no problem. And focus in 42, 43, and 44, que is a problem specifically in this part. The rationalization binomial. Radical 5, radical 11, minus 3. No, minus or plus? It's plus. It's plus, no? Let me see. Yeah, it's plus. Okay, you identification. Well, identification, no. The problem say rationalize. Rationalize means eliminate any radical in the denominator. So I need to do something like that. Bam, eliminate this radical. How? Well, you create the smart one similar to the monomial, but the new thing que bring me is you copy the conjugate. What is the conjugate of this guy? Es radical 11 minus 3. Entonces, si this is a smart one, the expression on the top should be equal to the expression at the bottom because I take advantage that any expression divided by itself is 1. This is classical smart one. But no arbitrary, no crazy. It's a conjugate. This is the conjugate of this. So far, this idea is clear? So far, this idea is clear?
Yes.
Yes.
Now, the rest is piece okay. Look at that. The rest is... Okay. If you want your multiplication, for example, let's do a multiplication, the top first. Okay, it's easy. Is radical 5 times radical 11 is radical 55. I don't know si they work and leave it like that or no. And minus 3 times radical 5. That's it. We cannot do anything because remember the organization. This is a radical, coefficient is 1. This is another radical, coefficient is 1. 1 times 1 is 1, get this 1. And 5 times 11 is 55. So you can multiply only the number outside, inside. But when you have fixed, because 3 have no radical means, in my mind, get the number inside the radical 1. Remember, 1 is invisible, guys, invisible factors. So when you multiply, look at that, you multiply 1 times 3, get 3, and 5 times 1 get 5. So the answer is 3 radical 5. Okay? You don't complicate your life too much. This is, you multiply number outside and inside matching. Okay? It's illegal. The multiplication, one number outside and one number inside. No, because they are different categories. And the bottom is super easy si you take advantage of this formula. Multiplication of conjugate is equal square the first minus square the second. So you square this guy, it's obvious it's 11, no? Because radical 11 is square, cancel out, square power and radical. And 3 squared is 9. 3 squared is 9. and you separate by minus, no? Minus. Entonces, minus es 2, ¿no? 11 minus es 2. Boom, final answer. Final answer. Okay, no. See, you don't like, you don't understand very well this. I suppose que it's the easy way. No problema. You, one corner of the piece of paper, you take both binomial. By the way, they are family. That is a reason okay, we have shortcut. But you don't remember very well the shortcut, and you multiply radical 11 times radical 11 is 11. Radical 11 times minus 3 is minus 3 radical 11. Positive 3 times radical 11 is positive 3 radical 11. And positive 3 and negative 9 together is negative 9. And it's a cancel always, I guarantee you, and 11 minus 9. Either way. What way you prefer, the formula or FOIL? It's important for me to know what way you consider better for you. The formula for the difference of square power or FOIL?
The formula.
Me too. Okay, you know this fact. You know okay, they are family. Entonces, when you are doing the multiplication, the outer and the inner multiplication or inner product always cancel out and stay alive only first and last square and minus in between is the guy called A and B. So let me see what's the answer of that. Like a 55 minus 3 like a 5 divided by 2 is B. A ver, es B, yeah. Es B. Okay. More clear now? Tell me. More clear now? Okay. You can help me? And the next? And the next? For example,
we can try.
Come on, you try, of course. You are a student, you know? If you make a mistake, no problem. Okay, suppose this is given like that. Okay, entonces the question say rationalize, do something in order to rationalize denominator. What should I do? Tell me. Come on.
Smart one.
Smart one. Okay, you create the smart one, multiplication by the smart one. And what is the expression in the smart one? You don't know.
Graduate is the different sign.
Entonces, pero es 5 plus radical 2 o 5 minus radical 2?
5 minus.
Because it's the conjugate of the expression in the denominator. So, 2. So, the important in this moment is this guy. It's not important. You focus in the denominator part, the part you want to rationalize, and you determine the conjugate is the same expression, copy, paste. However, you change the sign. The sign in the middle, one sign. And this is my new smart one. Okay. So now suppose que I am doing this, it's easy. Square this guy is 25. Square this guy is 2. And subtract 23. You see too fast how we are doing the multiplication this and this. The multiplication this and this is different. Bueno, it's a family. They are twin brothers. This is brother, no brother and sister. This is conjugate. So you are doing multiplication of conjugate. I understand very well. But now we are doing the multiplication twin brother. And the multiplication twin brother, when you multiply the guys, a plus b or a minus b, either way, plus and minus, times itself is a squared again, plus and minus twice ab plus b squared. It's a formula. This formula is not new for you when you see perfect square trinomial, no? Because actually you can represent this like a plus and minus b squared, no? You know que the square refers the same sign in this example is minus. You introduce a coefficient of 2 because in conjugate you get opposite sign and cancel out 0. But in twin brother, no. You get exactly the same and you increasing is double. Okay? And the rest is the same, but it's plus. Okay, it's a formula. That's okay. So you say, no, I don't like the formula. Too much formula. You say, now you foil. 5 times 5, 25. This 25 represents this. And 5 times radical 2 is minus 5 radical 2. And radical 2 times 5 or minus is minus. Do you see a difference? You see in twin brothers have the same sign, not opposite. In conjugate, yes. That is a reason that you simplify. Okay, and finally, radical minus radical 2 is positive, radical 2 times radical 2 is 2. Is this guy. And what about this, professor? You say it's 2? Because this and this is the same. It's 25 minus 10 radical 2. Because 5, negative 5 and negative 5 together is negative 10. So we are doing similar to the problem we were doing before, in which you have like term and you add in the coefficients. Actually, the idea behind this is minus 5 radical 2. Minus 5 radical 2. How do you know, professor? Are you adding or subtracting this? Because you factor out negative 5. So you have radical 2 plus radical 2. And radical 2 plus radical 2 is 2 radical 2. Twice. It's a double, no? 2 radical 2. And this negative 5 and this 2 is 10. Negative 10, of course. That's what the final answer. Well, the final answer in the top is 25. 25, no. 25 plus 2 is 27. Minus 10. Radical 2 divided by 23. I'll leave it like that because, you know, 23 is prime number. Okay, it's 27 minus 10. Radical 2 over 23 is the option A. Confusing, eh? Well, more clear now. The problem is in algebra, we have to, okay, good. In algebra, hey guys, yes, I get now. Okay, the problem, Anika, is in algebra, we have the classical foil. You apply always, anytime, when the binomial is no family. They're completely different. Suppose another thing, C. However, we can apply shortcut to do quick foil into a scenario. Scenario number 1 conjugate is A plus B, A minus B, or they are conjugate special, the family is A squared minus B squared. You apply this in both directions. You apply in this direction and the multiplication, that's the thing we're doing now, but you apply this in the factorization. Is the thing we're doing in the chapter 3. And we have twins. Twin is A plus B times A plus B. By the way, is A plus B squared. You realize, it's important to think of what to say now. A plus B and A squared plus B squared is not the same. A typical mistake, stupid mistake. Okay, stupid mistake. Actually, this is square first plus twice multiplication both B squared. Okay, this is twin brothers. Twins says no T in the last, twins. Plural. You see que A square, this is logical. Look at that, look at the geometrically, suppose geometrically. Suppose that we have one square. It's AA. And suppose that we have another square. A square. I try to do my best. PB. This is A square and this is B square. However, A plus B included that part. It's a two rectangle and the dimension is A and B. So the area is AB and this area is AB. So it's 2AB is that part. Okay, so this is stupid. Erase this in your mind. Never. Okay? This is geometrical interpretation. The antichi mathematician visualize everything geometrically because before this we have no algebra. The algebra do not exist. So this manipulation we are doing now today, we are doing verbally or in geometric interpretation. Because remember, this mathematician, they are very, very concrete. They want to solve a real life problem. No, get a problem. To say now, algebra open the door to visualize more clear. And this idea, this procedure that we studied today was created in the 17th century. Before this, there are a genius, the mathematicians, they don't know the way that we are applying the algebra. Okay, entonces radical 7 over 7 radical 6. Wow, look like weird. But I suppose que no. What should I do? Help me. You only give me the idea. No detail. You see. Professor, you do something. Multiplication, blah, 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 blah. Come on, try. Nobody want to participate. Remember, participation is important. Participation. I consider like an extra credit in the final grade.
You should conjugate now.
You say what?
Conjugate.
Conjugate. Okay, entonces, what is the conjugate, in your opinion? What your name is? Anika, no?
Michelle.
Michelle. Michelle what? Peñalver?
Yes.
Okay. What is the conjugate? Help me.
So we can do FOIL or the formula.
No, but before that, what is the conjugate? What should I do to find it? What is the conjugate of this? What is the conjugate of this? What is the family of this? But no twin brother, conjugate. What is that? Come on, another participation. No, Michelle. Michelle have idea, but no complete idea. Come on. Nobody? No? Sure.
Chain design.
Chain design. Chain design means 7 radical 6 plus radical 7. Anything you try to explain? Yes or no?
Yes.
And the top, you copy the same, no? Remember, this guy is a smart one. Okay, who helped me to do the multiplication of the top part? The top part is easy because it's monomial expression. And this is binomial expression. Okay, now the multiplication is just apply distributive. Multiply this times this, and this times this. But be careful, because remember, we cannot mix it number and the inside the radical and outside the radical. So when you multiply, I suppose that the outside here is invisible one. And here I know invisible one. And when you multiply, this is 7 radical 42. Yes or no? Do you understand where I come from 42? 7 times 6.
Yes.
And radical 7 times radical 7 is 7. I know this fact. Okay, who helped me with the multiplication that part? Remember, a square. A square this is, well, it's 7 squared. And the square root 6 square, no? 49 times 6. I put in my calculator. 49 times 6 is 294. And this guy square is 7, no? So we have 294 is a squared minus 7. You subtracting 7 is 284. This together is 287. Entonces I try, I don't know if it's possible or impossible to simplification a little bit. So this answer is look like horrible. Actually, we have 7 like a 42 plus 7 divided by 287. But 287, let me try to investigate if it's divisible by 7. Oh yes, it's 7 and 41. And my calculator, of course. And you factor out here 7. So 7 out, common factor, is radical 42 plus 1. No? It's obvious that this 7 and this 7 is cancelled. The answer is radical 42 plus 1 divided by 41. I suppose we cannot do anything more because 41 is prime. You try, you don't know, you try. 287 is prime, no. It's divisible by 7. It's a multiplication to prime numbers, 7 and 41. So I investigate the only possibility we have in the top is 7, the common factor. Let me investigate, you put in the calculator 287 divided by 7, oh, it's 41. So basically, 287 is 7 and 41. It's the prime factorization. And the 7 in the top after the factorization. Remember, you cancel out when you have multiplication. AB, CA, you cancel out. But A plus B divided by C plus A, you cannot cancel out this and this. No. Yes. This is violation. Okay, let me check the answer. The answer is 42, square root 42 plus 1 over 41 plus. It's the option A. Okay, let's move on now. You have no question?
Well, I have a question. Where did plus 7 go?
Plus 7. Ah, it's the conjugate. Okay. It's the conjugate, miss. Okay, look. The idea is... Okay.
At the end, before you simplify, where did plus 7 go?
Okay. The original is 7 radical 6 minus radical 7. This is the given. Well, one radical 7 here. But I explained the strategy, the simplification of these examples is multiplied by a smart one, is formed by conjugate. And conjugate, you need to know the meaning of this word. Conjugate is exactly the same expression. You copy 7 radical 6 and radical 7, but opposite side plus. It's a conjugate. Of course, you say, wow, you multiply by this to affect. No, it doesn't affect because I multiply and divide by the same. And it's working like a smart one, because the guy can help me to amazing magic simplification of my problem. Okay?
Yeah, Professor, I'm referring to the last step, the +7 in the last step.
In the last step, I see here in the top, you can see 7 is greatly common factor. I factor out. And investigate using my calculator. This is 7 and 41. Therefore, this 7 is cancelled. But it's important that you simplification, you factorization first. This is your question, miss? No?
Yes, that was my question.
Cool. Okay. Guys, practice. Using the homework and pretest. Pretest, I don't care too much, but the homework, yes, it's extra point. No? That you it's useful for two reasons. Reason number one, practice. Reason number two, you have extra point. Okay. Let's focus in the multiplication. Look at that. That part. Okay. Here is the combination, any possibility. Example 38 is radical 2 minus 6 and radical 7 minus 4. Oh. This is two binomial and they are no family. No, it's completely different binomial. Therefore, you apply FOIL. No, they are not shortcut. They are not quick FOIL. And you multiply. Radical 2 and radical 7 is radical 14. If you want. Remember, you can multiply number inside, because outside is invisible one. Like this. Now multiplication is this and this is minus 4 radical 2. Okay. Inner is minus 6 radical 7. And last is positive 24. Guys, and unfortunately, we cannot do anything in this simplification. Well, you say, well, maybe this fraction, well, 14 is no primary, but 14 is 2 and 7. We have no couple. There's no simplification. This is the answer that corresponds perfectly with the option B. In this case, no family. Therefore, you just FOIL. It was 38. And 39, we have family because we have twin brother, 3 plus radical 2 squared. Some students prefer doing FOIL all the time. Okay, I respect that. Another student, no. Another student prefer the formula. We're doing both ways. Suppose, both ways. I want to copy 3 plus radical 2, 3 plus radical 2. I don't understand, never understand what is the family, what is the new way, what is the shortcut. Okay, no problem. You multiply 4 is 9, 3 times 3 is 9. 3 radical 2 is 3 radical 2. Radical 2 times 3, I put 3 radical 2. And expecting this answer because they are twin brothers, it's the same. And radical 2 times radical 2 is 2. Entonces 9 and 2 together is 11. And 3 plus 3 is 6. Boom. Another way to visualize this idea, no foil, this was foil, is you remember the formula. The formula says square the first, 3 squared is 9, plus multiplication A and B together, and extra 2, 2 times 3, and radical 2, plus square the second, que es 2. Entonces, well, you have 9 plus 6 radical 2, multiplication 2 and 3, plus is 11, plus 6 radical 2. Formula? And 4. Either way. What formula? That formula. A plus B. A squared is square the first, twice AB plus B squared. Maybe in this subject, it's not strictly mandatory doing that way. But when you advance in mathematics, you take color algebra, you take pre-calculus. This operation you need to do fast. And doing by foil is, you know, ridiculous. Okay? But okay, I respect. Anyway. 30, 39, no? Now 30, 30, 30, 40, 40, 40, 40. 40 is another twin brother, look. 40 is 3 minus 2 radical 3 squared. You apply the formula, 3 squared is 9, minus, in this case, minus, because when the sign here is minus in the first. In the second, always is positive. Multiplication each other is 6, 3 times 2 is 6 times extra 2 is 12. Radical 3 plus a square de this case 2 square is 4 and square radical 3 is 3 and 4 times 3 is 12. Okay, now is 21. 21 minus 12. See, this one. Okay, do you understand that part or no? Yes or no? Because I can do it step by step.
Professor, I don't understand why it was 12. Last part.
12 was the result of 2 radical 3 squared. 2 radical 3 squared is 2 squared and radical 3 squared. And 2 squared 4 and radical 3 squared is 3, no? Because the square power and the square root cancel out. And the answer is 12. Clear now?
Yes. Thank you.
And this, the middle, do you understand where I come from 12, radical 3 or no?
Yes, I understand.
Everyone follow me? One more is, this is easy, 41. 41 is radical 6 plus 1 and radical 6 minus 1. So I immediately recognize que it's the conjugate. And the conjugate is super easy. Is you take square this is 6. This is A, this is B, this is A, this is B, this is A squared minus B squared, no? Entonces now radical 6 squared is 6 and 1 squared 1 minus 1, entonces 5. Wow, Amazing. The answer is 5, yes. Look at that. Cool. Do you see the power of the shortcut? So you don't remember the shortcut? Okay, you definitely we can do, but it's too long using FOIL. Okay? Suppose let's do it by FOIL. Radical 6 times radical 6 is 6. Radical 6 times -1 is minus radical 6. 1 times radical 6 is plus radical 6. And negative positive 1 and -1 is negative. And always this cancel. And the conjugate. The answer is 5. Wow, amazing, right? Cool. I suppose that we have no more page in the practice. Let's spend the rest of the time doing the review. Guys, try to do your best in this test, because the 5 test, the 5 chat is super easy. So you are doing well in this, you pass the class. Okay, actually we are doing more than 50%, no? And now this chat, in my opinion, is easy, you know, but okay, let's do it now. This is the review. This is the review. We're doing something here. We're doing something Monday. Okay, so we have number 1 is, what should I do? Determine what, the value in which the rational expression to be undefined. I understand now. Okay. You. This is a classical question. You never practice this. That's easy. Let me show you. Okay, so now to be undefined means undefined is when the division is 0, so you have any number divided by 0, the answer is undefined. No exist error. To investigate that SEC, you take the expression in the denominator, that part. I don't care. The expression in the numerator, this is not important. And you enforce it to be 0. That one. If you solve this elementary equation, es obvio que x es 4. Entonces, what the interpretation of this? Interpretation is determine the value that make rational expression to be undefined x 4. Putting 4 here, the answer is undefined. And number 2 is x squared minus 4x minus 45 divided by x squared minus 9. Same thing. We focus it 100% in the bottom part. I ignore, I don't care the numerator part. No, it's not important. Entonces now you take the expression que es x squared minus 9 equals 0. Okay, this is different to this. That was linear equation. This now is a quadratic equation. Quadratic equation, not always, but almost. We have 2 solutions. But I realized that the binomial, and this binomial is the difference of square, and the factorization is xx33 because the square root 9 is 3 plus and minus. Therefore, you apply one more time the 0 factor property. You separate each factor 1 by 1 equals 0 because this product is 0 when this guy, the first is 0, or the second is 0, or both are 0, no? Entonces the solution is -3 and +3. In this case, we have 2 values. Okay, to be undefined, the expression number 2, -3 and +3. Cool? This is no big deal, but it's important. I promise again, in college algebra, we are using this. Investigate domain, the function. Entonces now I need to avoid to be undefined. Entonces when it's a fraction, you take the expression and the denominator. I ignore, I don't care. The expression in the numerator, no important. Because the expression in the numerator is 0, the answer is 0. So it's important to keep in mind this idea. Look, let me show you. 0 is a complicated guy. 0 divided by any number is 0. Any number divided by 0. Oh, this is the big problem. It's undefined. Okay. Because it's impossible division by 0. Okay, let's obey a couple of equations. The rational equation, okay, you know, they are a little bit complicated because you need to find least common denominator. Suppose the number 3. Esa equation, entonces, solve. Solve means que when you manipulate, the final answer is x equals something. And verification with the restrictions. See, we have restriction on. Well, in this case, it's super easy because we have the same denominator.
Professor, sorry, the last part is 4, is the 4/7.
Oh, yeah. Crazy. Thank you. 4/7. Okay, entonces one possibility is in this scenario, okay, we have the same denominator. I take advantage because we don't need to find least common denominator. So when you have two fractions, 6, you can condensing this and this in only one because it's the same denominator. So in the top we have 6 minus 8 is negative 2. Do you see the transformation? That transformation?
Yes.
It's the only possibility, you know. So the majority of the scenario, when you have different denominator here and here, is the thing you need to find least common denominator, blah, 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 blah. In this case, also, is proportion. And proportion is easy because you apply cross multiply like that, bam, bam. But keep in mind restriction. The restriction is, you know, is x no negative 5. Because what happens when there's negative 5? Negative 5 here, negative 5 plus 5 is 0 on the 5. So you copy this for the future. When you finish to solve it, the answer negative 5, I know this solution is invalid. However, it's different to negative 5, I am happy. That's it. You cross multiply is negative 14, negative 2 times 7, and on the other hand, we have 4x plus 5. And you apply distributive. This is algebra. X plus 20, no? Now, what should I do? Well, I move 20 to the other side, minus 14, minus 20, equal 4x. This is minus 34, x divided by 4, both sides. And just in case you put in the calculator, 34 divided by 4, I suppose it's a fraction. 34 is divisible by 2 is 17. So we can reduce the lowest term. So we have x alone here. And we have minus something divided by something. So 34 is 2 and 17. And 4 is 2 and 2, no? At least 1, 2 is cancelled. The 17, final. And this answer is no coincidence. no matching with the restriction, so we have no problem. No problem. This is the answer. The answer is x equal minus 17 over 2. Cool?
Yes.
Let's do it one more and that's it. That's it. Case number 4. Monday we continue this review. Sure. Okay. You have, okay, remember you have, today I sent this review in PDF and the test number on paper. And it's the 2 I say at the beginning, October 5th. It's next Monday, no? I do have this entire weekend.
That is a Wednesday.
It's a Wednesday. Oh, let me see the calendar. Let me see I do it well or not. So we have 2 activities before this. Okay, it's October, September, October. Yeah, it's Wednesday. Okay, so Monday we continue review, and Wednesday we start new chapter. Okay, chapter 5 is the last one. But you need to turn into me the test on paper and submit. I need to fix it the due date in Alex, okay, for the test number 4 and the homework.
Thank you.
No, it's okay. It's a hurricane problem, no? Okay, now let's do one more and that's it. Okay, remember, you got me. I know that this problem have too many steps. I copy 40 over x minus 2 equal 1. No, equal no, it's minus, no? Minus, yes, it's minus. It's minus. Equal 42 over x plus 2. In this case, we have completely different denominator. And you find LCD. Well, before LCD, factorization, no? But factorization, you know, is completely impossible because x minus 2 and x plus 2 is prime number. And the LCD is the collection of x minus 2 and x plus 2 together. And that's it. And the restriction associated with this LCD is x no 2 and x no negative 2. It's illegal solutions. Restriction, bad guy. And now multiplication, the entire equation by the LCD. And magically, when you are doing this action, the fraction is gone, disappears. Now, in the first fraction, it's obvious that x minus 2 is cancelled, and it stay alive 40 multiplication by x plus 2. Minus, in 1 we have no fraction, no fraction. Therefore, it stay both. It's x minus 2, x plus 2. Equal, and this case, you cancel out x plus 2, stay 42, x minus 2. Do you follow me?
Yes.
The rest is algebra, baby algebra, no big deal. But let me be careful because this minus is confusing. And for me, I prefer to put the bracket here because this minus affect not only x minus 2, affect both. You for it, 40x plus 80. This minus bracket, and you multiply this. Oh, but again, I saw multiplication conjugate. And multiplication conjugate, I know very well, que is square the first minus square the second, que 4. Do you see that or no? Not necessary for it. Do you see or no?
Yes.
Now, this 42x, the right-hand side, minus 84. Okay, not bad. Now, be careful. This now look like quadratic equation. The responsibility to be quadratic is these two. You have these two, the quadratic. But si es quadratic, I know that I need to organize the equation in standard. And put the right hand side or left hand side either way, 0. Entonces now I have 40x plus 80. This minus affect everything. It's minus x squared plus 4. Cool. I move everything to the left, maybe. Minus 42x plus 84 equal 0. Now ready to combine later and organize in descending order of degree. Okay, degree 2 is this guy, is minus x squared. Degree 1 is this and this, is minus 2 x. 40 minus 42. And degree 0 is this, and this. And everything is positive, no? So it's 84, 80 plus 4 is 84, and 84. This is weird. Let me see. I am doing well, guys. I suppose, no? I don't know. 80, 84 plus 84, no? 84 times 2. It's 100. Close, no? 168 equals 0. I don't feel comfortable with this equation when the sign here is negative. Entonces I multiply. Bueno, this entire equation by -1. Look, if you multiply, you get x squared 2x minus 168 equals 0. I try to do my best in the factorization. This factorization is horrible. I see if it's good or no. If it's not good, that's because I make a mistake. Factorization in the calculator. See the combinations. Yes. Factorization, guys, is 12 and 14. Because in my calculator, I tried the combination 168 and 12 and 14 multiply each other, give me 168, and subtracting give me 2. So, no, negative and positive. Okay, now I separate. Separate the first solution as x minus 12 equals 0. That means x is 12. And x plus 14 equals 0. X negative 14. Wow. Final answer. Well, let me see if matching or not with the restriction. The restriction was 2 and negative 2. No problema. Okay, the solution of this equation is 2 solutions, and both solutions were 12 and negative 14. Cool? No problema. Very well. Let's stop. No more. I have another class guy now. Okay, super, Eric. Okay.
Thank you, Professor.
Oh, my pleasure anytime. Okay, bye-bye, everyone. Have a nice day.
Bye, Professor.